In this worksheet, we're going to look at how we can experimentally determine what the formula for a compound is. And the first step in doing that is to write down what the element's percent composition is. And what a percent composition is it's what percent element you have in the compound. And that's equal to the mass of the element per mass of the compound. Now if we want it to be a percentage, we're going to have to multiply that by 100%. Let's put a box around this. This is worth remembering. All right, now suppose I've got some compound. Suppose I have 8.657 grams of compound. And I decompose it into its elements. And I get from that 5.217 grams of carbon, 0.9620 grams of hydrogen, and 2.478 grams of oxygen. And I want to know what's the percent composition of this compound. All right, well, I can just use this formula to do it. The mass of the compound is here, and the mass of the element is here. There's 3 different percentages. And I have a check in the end. If these are the only elements that are in the compound, all the percents that I figure out should add up to 100%. Let's just do the percent carbon, and you try the rest. Okay, the mass of the element is 5.217, and the mass of the compound is 8.657 times 100%. So let's see, what do I get? You should try it yourself. You should get 60.26% carbon. Now you try doing the hydrogen and the oxygen this way and see if all of your percents add up to 100%. And then you've got it. Now sometimes we're going to be able to go the other way. Here you had the masses of the compound and the mass of the element. But sometimes you can figure out the percent element even without that. Here is a common air pollutant. If I give you the formula for that, you can actually figure out the percent composition with just that information. So how? Well, we're going to use this formula again. If I want to look at how many grams of nitrogen are in here, what does this formula tell me? It tells me that there's 2 moles of nitrogen in every 1 mole of compound. Right? Because that's what the subscript there is telling me. 2 moles of nitrogen for every 1 mole of compound. Now, I can turn this into a weight using the molar mass of nitrogen. Molar mass of nitrogen is 14.01 from my periodic table that I have over here. So how do I figure out how many grams that is? 2 moles of nitrogen times 14.01 grams of nitrogen per 1 mole of nitrogen equals what? 28.02, right? So there I got how many grams of nitrogen I have in the compound. Now I have 1 mole of compound. I can turn that into a mass too. I need to know the molar mass of this. And the first couple of questions on your worksheet are having you go and actually figure out the molar mass for the compound and nothing else. Now, I have to remember how to do that. We did that a while ago. You got 2 moles of nitrogen, so it's 2 times the molar mass of nitrogen. We said it was this. Plus 5 times the molar mass of oxygen, which is about 16.00. So 2 times 14.01, that's 28.02, plus 5 times 16. 5 times 16 is like 80, so it's like 108.02, yeah, grams of N2O5 is 1 mole of N2O5. That's the molar mass of N2O5. So here's the grams of nitrogen, and here's the grams of N2O5 I've got in 1 mole of compound. So the percent nitrogen is 28.02 over 108.02 times 100%. Let's see. So that's about a quarter, like 25 out of 100 is like a quarter, so it'll be something close to that. Excuse me. If I figure it out, it comes out to be that. See if you get that same number. That's the percent nitrogen in the compound. All right, so how do you find the percent oxygen? Now we could go through the same procedure here. We could say, well, this formula here tells us that there are 5 moles of O in 1 mole of compound. So I could say, well, oxygen is 16 grams per mole. So for the oxygen part, what am I going to get? 5 times 16 is like 80, right? I guess if I use significant figures, it'll be this. And I still have 1 mole of compound, which we figured out up here was 108.02. So the percent oxygen would be 80 grams of O per 108.02 grams of compound times 100%, which if you do the math, it's going to be what? Well, if this was like 25% up here, this will be like 75%. And I think if we do the math, it's going to be a little less than 75%. It'll be that. So these are the 2% that you get for the percentage composition. That percent oxygen and that percent nitrogen. Now, we could have figured out what the percent oxygen was a lot more simply than we just did. I mean, we just went through the whole thing so that we could use the formula for percent oxygen there. But what you could have done was, once you figured out what the percent nitrogen was, you could say the percent oxygen, since it's the only other thing that's in there, it has to be 100% minus the 25.94%. So that's either a check on it or an easier way to do it, up to you. You can do it the hard way and then check it. You can also check it by making sure that both of your percentages add up to 100%. And if they do, then you did everything right. All right, so there's a couple of questions on the worksheet that are going to have you practice these 2 forms. Sometimes you will have the mass of the element in the compound. You can figure out the percent. And sometimes you will have the formula and they want you to get the percent composition. And you'll do it like this. Write out for each subscript what mole ratio that is. A subscript 2 means 2 moles of that in 1 mole of compound. Then turn moles of this into grams and moles of this into grams, and use the formula for percent composition to get the percent. And that's how you can do those questions.